Okay, now for the last in our sort of quadratic series, and that is to look at quadratic inequalities. Again, something we have looked at. We're going to just, because we're just lingering with this just a little longer, we're going to look at two methods really. I think you know the most effective method that I think there is, and that is using the graphical method. But I'm going to show you an algebraic method as well, and it all adds to the richness of your mathematical experience. So let's just get straight into an example of a quadratic inequality. Hopefully you appreciate that they're just not as straightforward as quadratic equations. It's not just a matter of running out a factorization and a straight solve from there. It's just one or two more layers involved, aren't there? So, all right, so let's have a look at an example. So solve quadratic inequality 2x squared minus 5x minus 3 is greater than or equal to 0. Okay. So the method, as with equations, is to factorize where you can. Okay, so let's look to do that and then see what we're left with. Looking for two numbers that multiply here to -6 and add to -5. So that looks to me like -6 and 1. So we're in business, we can factorize. So therefore, and again, look, you want to pause and do this. It might be, I kind of want you to have a look at the two methods. And then I'm going to finish this video with a problem that sort of links in the last unit on discriminant and this quadratic inequalities to solve a sort of a bumpy question. Okay, so I'm looking to factorize here. I've got, and even though this is one that's probably quite easily factorized by guess and check, I'm sort of into a more methodical method, a more precise method might be the word I'm looking for. So that's why I'm splitting as I am. So 2x, x minus 3, plus 1, x minus 3. I know this is going to deliver the results for me. 2x plus 1, x minus 3. So I've factorized and I have my inequality. Okay, at this point, we're going to go through two. We're going to have a look at two methods. Okay, the first method we'll look at is we'll have a look at the algebraic method, and then we'll have a look at the graphical method. Algebraic method. So the algebraic method is one that just goes through all the possibilities. So if I've got the product of two expressions turning out to be positive, which is what we've got here, then my two expressions can be both positive or both negative. And that's what the algebraic method is going to exhaustively look at. So the algebraic method. So what I'm going to do here is I'm going to say, okay, for 2x plus 1 and multiply by x minus 3 to be greater than equal to 0. So for this to be the case, then I need a positive times a positive. So I need them both expressions to be positive, or I need them both to be negative. Okay, so this is the positive case. Okay, the positive case we'll look at first. And that means that for that I need 2x plus 1 to be greater than or equal to 0, actually. And that's an important word, x minus 3 to be greater than or equal to 0. So therefore I need x to be greater than or equal to -1/2 and, not or, but and x to be greater than or equal to 3. Righto, so which of these inequalities do I take forward? Because what this says is that I need both of these to be satisfied. So if I get myself a little number line here, then, all right, if I've got 0 here, and I've got -1/2 here, and I've got 3 here, I've got x is greater than or equal to 3, so that's 3 there greater than or equal to, and to all those values, and it's less than or equal to negative a half. Less than or equal to negative a half. So, sorry, it's greater than or equal to negative a half. So I don't know what I was talking about there. I just need to turn this guy around. So I'm going this way from negative a half. So what are my solutions that solve both of those inequalities? Well, it's this here, isn't it? These values here. So that's the one that wins. X is greater than or equal to 3. So when x is greater than or equal to 3, then I've got a quadratic expression here that is greater than or equal to 0, because my 2x plus 1 will be greater than 3. Will be positive, and my x minus 3 expression will also be positive. So that I can take that forward. Now my negative case. Okay. So now we look at 2x plus 1 being less than or equal to 0 and x minus 3 being less than or equal to 0. So therefore, x is less than or equal to negative a half and x is less than or equal to 3. Let's get my ruler back out and have a look at these solutions. Okay, so there's my negative a half again. Anchor it with 0 here and put 3 down here. So x is less than or equal to negative a half. So this time I'm going this way. And x is less than or equal to 3. And highlight this word here. So what values of x satisfy both those conditions? Well, in this case, it's here, isn't it? Right, all those values are both less than negative a half and also less than 3, less than or equal to 3. So when x is less than negative a half, I've got both of my factors being negative, and the product of two negatives gives me a positive. So therefore I can say that x is greater than 3 or equal to 3, or, now it's an or, x is less than or equal to negative a half. Okay, they're my two branches that solve this inequality. If I was solving less than 0, it's worth pointing out, then I'd be looking for alternating signs. I'd look at positive, negative, and negative, positive, and I would look to find, again, the values of x that solved both. So and would be the key point there. So that's the algebraic method. Let's go to the graphical method. Now this is the one I use, and it's the one that we have used when we have been solving, and we have done some solving of quadratic inequalities. This is not new, but it's part of the course, and this is an area of the course where you won't be sort of getting exam questions so much on specifically solving quadratic inequalities, but you need to know it in order to push through some other areas of the course. It'll be absolutely prerequisite stuff. So the graphical method. So in this method, as you know, we've got it factorized to 2x plus 1, x minus 3, and then what we do is we take this and we graph y equals that, don't we? We graph y equals 2x plus 1, x minus 3. All right, so we'll go and have a look at the graph of that. So the benefits here are that we can quickly see a solution. So negative a half. So if we're graphing this, these are our important points. Again, just as we did with our number line over here, but this we're just looking in 2 dimensions now. We're looking at, again, our key points are negative a half and 3. And we've got, what we're doing is we're graphing this quadratic. So we're always going to be graphing a concave up, right? Whatever we've presented with here, we're going to change it around. We might need to change our inequality around, but we're always going to have positive x squared. So in this, we're always going to be graphing a parabola that is concave up. And I don't really care so much what it looks like, because all I'm doing is I'm representing the parabola, and I'm going to focus very quickly here in on what my positive and negative values are. So I've graphed this equation. Now I'm looking for, and now, So once I've graphed it, now look for the values of x that result in y being less than or equal to 0. Is that what we're solving? Sorry, greater than or equal to 0. My mistake. Y is greater than or equal to 0. Now look for the values of x that result in y being greater than or equal to 0. Well, they are, and I might just get a thicker pen out for this. They're going to be here and here. These are my spots. These are the parts of the graph where y is greater than or equal to 0. They're my greater than or equals branches. But what I'm actually looking for the values of x which result in those. So here are my values of x that result in positive values of y. Okay, so what are those values of x? Well, they're greater than or equal to 3, and they're less than or equal to negative 1/2. So you take your pick about which method you'd like to use, but I reckon that is quicker. X is greater than or equal to 3, or x is less than or equal to negative 1/2. If I was solving for less than 0, it would be an included range in between negative 1.5 in this case, and I would write it like so. I would always write it like where x is in the middle, where and in between two values. That's how you would write it in that case. Okay, so quadratic inequalities. I have a let's have a think for a second. So okay, so let's just I would like to actually just do that example, but it's so it's going to be the same example, but now let's solve 2x squared. What is it? 2x squared minus 5x minus 3 is less than 0. Minus 5x minus 3 is less than 0. So we're doing the same question. I just want to demonstrate it's 2x plus 1, x minus 3. So we would go ahead and factorize is less than 0. So now just going to do the graphical approach. I would have put a set of axes down here. So I would have, again, my negative 1/2 and 3, and I'm still going through, that's negative 1/2 and that's 3. This is my x-axis, this is my y-axis, and I would have my parabola going through those 2 points. And I'm just showcasing now what happens when you're solving less than 0. The elements here that are less than 0 are in here. These are my values of y that are less than 0. So my values of x that result in y being less than 0 are these values of x. Now I'd take note that it's less than, not less than or equal to. So I would give my solution therefore as between negative 1/2 and 3. And so that is how we write the solution when it's an included range of values from a minimum to a maximum value. Now, one question that ties in the discriminant, and I'd like you to copy this question down and I'd like you to solve it, please. Okay, here is your prep question well, this is Friday's lesson, isn't it? So this should be done, I guess, in time for to put up in your prep folder by Monday morning. Okay, end of the lesson. Cheers.